Good day, everyone. I am King Jacob and Javier, and I am going to report the topic on bevel gears. Bevel gear is a type of a gear that is used to transmit power between intersecting shafts that are at an angle to each other. So basically, there are five types of bevel gear. The first type is the straight teeth bevel gears. The straight teeth bevel gear is characterized by their teeth which are straight and parallel to the axis of rotation. These gears are designed to mesh with each other at a specific angle, typically 90 degrees, although other angles are also possible. For the next type of bevel gear is the spiral teeth bevel gears. It is a curve or spiral shape instead of being straight. The spiral teeth allows the gears to engage gradually and smoothly, reducing the noise and vibration during the operation. For the third type of bevel gear is the serral bevel gears. It is a type of mechanical gear system with curved teeth that combine the characteristics of straight and spiral bevel gears. For the fourth type of bevel gear is the hypoid gear. It's a type of mechanical gear system that transmit rotational motion between non-intersecting, non-parallel shaft with the axis of gears, forming a hypoid angle. For the fifth type of the bevel gear is the spheroid gears. It is a type of mechanical gear system that combines the features of spiral bevel gear and worm gear, providing both rotational motion and high gear ratios. For the application of bevel gear. So there are certain application of bevel gear in our industry. The first type is the differential of an automobile. It is used for transmitting power from the engine going through the rear wheels of a car. For the next type of application is the manual handrail, used for transmitting the power from the hand going through the chuck of the drill. The third type of the application is the gear-driven bicycle. It is unusual because we commonly see bicycles that are chain and sprocket driven. So for the definition of terms in the bevel gears, first is the pitch cone. It presents the idealized contact between the matting gears and is used to determine the gear size, position, and alignment. The next one is the pinion. It is the smaller bevel gear in the bevel gear set. Is usually the driver. For the next is the gear. The larger bevel gear, usually the driven in the gear set. For the next is the pitch, which is the distance between the centers of two consecutive teeth. The next is the addendum, is the upper part of a gear teeth, and the addendum is the bottom part of the gear teeth. For the summaries of formulas on a bevel gears. First one is the cutting or root angle. W is equals to Y minus the addendum angle. The second is a phase angle. B is equal to Y plus A. Third is the pitch angle. A for pinion. YP is equals to arctan of RP over RG. Also, YP is equals to arctan of NP over NG. And B for the gear. YG is equals to arctan of RG over RG. And YG is equals to arctan of NG over NG. For the phase speed, B is less than L over 3. For the fifth is the length of the cone. L is equals to square root of RP squared plus RG squared. The sixth one is the forking depth. WR is equals to 2 over PD. The seventh is the total depth. WR is equal to 2.188 over PD plus 0.002. It's an empirical formula. For the design calculations of the formula of bevel gear, first one is the strength of straight bevel gear. Fs is equals to SYB over PD times L minus B over L. Second type is a dynamic load FD 600 plus Vm over 600 FT. For the charts of the bevel gear, here's the chart that indicates the performance comparison of the gear type. The third is the bevel gears, ground serial bevel gears, and ground spiral bevel gears. And here is the table that is used in determining the sizing of the bevel gear, the number of teeth in the pinion, the number of teeth in the gear, working depth, tooth depth, gear addendum, pinion addendum, tooth thickness of gear, normal pressure angle, and spiral angle, also the shaft angle. So, sample problem in bevel gears. First problem is a bevel gear has a pitch diameter of 60 mm. Calculate the working depth of the gear. The given is the pitch diameter is equals to 60 mm. Solution, in calculating the working depth, we have work WR equals to 2 over PD. Substituting the 60 mm to the PD gives us the value of the working depth of 0.03 millimeters. That's all, and thank you.